welcome back to another lesson on oxidation and reduction, which we are dealing in redox reactions. So in a redox reaction, there would be an oxidizing part and reducing part. There would be something which is oxidized and something which is reduced. Today we are going to see a couple of reactions and in which we are going to find out which is oxidized and which is reduced. So let's go for it.
By the end of this video, you should be able to identify the oxidized and reduced part in any redox reactions. So let us take up some examples. The first example that we are going to take up is strontium and oxygen reaction. So strontium is reacting with oxygen to form strontium oxide. So how can we say oxidation and reduction, and what is oxidized and what is reduced? So by direct method, we can say that strontium is taking up oxygen, so it is oxidized. And the other, that is the oxygen, is reduced. We know that the oxidation state according to the rules, so it's just the element, so it is 0, and even for oxygen in oxygen, molecule is 0. But since this is an ionic compound, strontium oxide, we know that it is +2 and -2. So oxygen has -2 and strontium has +2. So if you observe the change the strontium is facing is a positive change. From 0 it has moved to +2. So there is an increase in the oxidation number. So we know that whenever there is an increase in the oxidation number, we have learned in terms of oxidation number, if there is an increase, then it is going to be an oxidation reaction. So we can easily tell that strontium is undergoing oxidation. Now, if you say oxygen, if you look at oxygen, we have oxygen is having 0 at the beginning, but it is having -2 after the reaction. So there is a decrease in oxidation number. So whenever there is a decrease in oxidation number, then it should be reduction. So strontium is oxidized and oxygen is reduced. If we take up another example, so the second example, we have a reaction between lithium and sulfur forming lithium sulfide. So we need to find out in this reaction which is oxidized and what is reduced. We know according to the rules lithium will have 0 because it is in the elemental form, and sulfur is also in the elemental form, it should be 0. But when you look at Li2S, that is lithium sulfide, lithium will have +1 charge and sulfur will have -2 as the charge. So what is the change? Lithium is facing a +1 change. So there is an increase in the oxidation number. So as the definition goes, whenever there is an increase in the oxidation number, it is the oxidation reaction. Therefore, lithium is undergoing oxidation. That indicates lithium is oxidized. We have the change for sulfur. Sulfur is 0. The oxidation number was 0 at the beginning, but it has moved down to negative, -2. So there is a decrease in oxidation number. And as per the oxidation number, if there is a decrease, then it is supposed to be a reduction, or sulfur is said to be reduced. So let us take up another example. So we have the third example. Cesium reacting with bromine. So in the product side, you get cesium bromide. So how do we see what is oxidized and what is reduced? So once again, cesium will have 0 oxidation number and bromine will have 0 as oxidation number. And if we look at the compound on the right side, the product side, it's an ionic compound. So cesium belonging to the first group will have +1 and Br is having -1. So cesium from 0, it has increased to +1. So the oxidation number of cesium is increased from 0 to +1. Therefore, it is going to be oxidation. that indicates that cesium is oxidized. We also have bromine, which was having oxidation number 0, but it has moved down to a negative term, that is -1. Therefore, there is a decrease in oxidation number, which indicates that bromine is reduced. So we have identified the oxidized part as well as we have found out the reduced part, that is bromine. Let us move on to another example. So that is the fourth example we are taking. So we have a reaction between magnesium and nitrogen. So what do we get? We get magnesium nitride. Now, if you look at the left side, we have magnesium, which should have oxidation number 0, and nitrogen also should have 0. But in the right side, we have magnesium nitride. Magnesium should have a charge of +2. It's an ionic compound once again, and nitride, as you know, should have 3 minus or -3. We can call it anyway. So there is an increase in charge, that's 0 to +2. So increase in the oxidation number. I repeat, there's an increase in the oxidation number. Therefore, magnesium is oxidized. It's undergoing oxidation. And nitrogen is undergoing reduction because it is moving from 0 to 3 minus or -3. So there is a decrease in oxidation number. Therefore, nitrogen is reduced. So we can identify magnesium is oxidized and nitrogen is reduced. So let's take up another example. So this is the fifth example. So what do we have? We have a chlorine molecule and sodium bromide, giving sodium chloride and bromine. So we understand that there is chlorine, there's sodium bromide, there's sodium chloride and bromine once again. So there is some interconversions. So first thing we need to do is make ionic equations as we have learned ionic equations. So how to go about ionic equations? We need to write the same reactants, but we need to split the ions in the ionic compound. So sodium bromide we have split up into sodium, that is 2Na plus 2Br minus, because we have 2 NaBr. Similarly, 2 Na plus and 2 Cl minus plus Br2. We are leaving Br2 as well as the chlorine as it is. So if you observe in this reaction, we have Na plus on both sides. So we can cancel out Na plus, leaving behind the ionic equation. So the ionic equation that we have here is Cl2 plus 2Br minus, giving you 2Cl minus plus Br2. So we can easily find out the oxidation number of chlorine is 0 because it's elemental. Then we have Br as -1, Cl is -1, and Br2 is 0. It's very evident that chlorine had 0 and it has moved to -1. So that means there is a decrease in oxidation number. So there is a decrease in the oxidation number, indicates Cl2 is reduced. So in the other case, Br minus, from -1 it has moved down to 0, moved up to 0, so it is increase in the oxidation number. That indicates that Cl2 has decreased, so it is reduced, and Br minus has increased in oxidation number, therefore it is oxidized. So one thing we have followed here is we have converted into ionic equation, then it was easy for us to find out which is oxidized and which is reduced. Let us take up another example. So we have a sixth example. So we have a reaction here wherein we have sodium and water. So the product, we are going to get sodium hydroxide and hydrogen. So hydrogen gas is given out. So how do you go about? Once again, we have to consider making an ionic equation. So if you want to make an ionic equation, so we need to keep up the things which are in the uncombined state. So sodium, I have kept it the same way. So water actually can be separated into its ions. So we have 2H plus 2OH minus, because H plus and OH minus are the ions of water. And as you know, Na plus we can separate and OH minus we can separate. We have written 2Na plus and 2OH minus because we have 2 NaOH. So if you cancel out 2OH minus, we will end up with the ionic equation. That is 2Na plus 2H plus giving 2Na plus H2. So now we can easily find out the changes in oxidation number. In the case of sodium, we have the oxidation number 0, and it has moved to 0 to +1. So there is an increase in the oxidation number. Therefore, sodium is oxidized. The next question is whether hydrogen in water, or water itself, is oxidized or reduced. So we already found out sodium is oxidized, but if you check out the ionic equation H plus, we see that the +1 from left hand side is reduced to 0 in the right hand side. Therefore, there is a decrease in oxidation number. Therefore, water becomes the one which is reduced. So water is getting reduced, so reduction is happening on water. So we already found out that sodium is oxidized and water is reduced.
I really hope these example problems of finding out which is oxidized and which is reduced helped you. Thank you for watching. Till then, signing off, Edberg Soans.